Hello all. Now in this session, the agenda is to explore about what is Newton's first law, where we need to study about frame of reference, inertia, force, how to identify the force in the universe or nature, Newton's second law, what do you mean by impulse, and the type of forces, Newton's third law, about action and reaction, followed by law of conservation of linear momentum. So these are the topics what we need to be projected through this particular lesson. Let us see one by one. Now, frame of reference. What do you mean by a frame of reference? Frame of reference means the system with respect to which the position or motion of a body is represented, known as a frame of reference. The coordinate system with respect to a particular person can be described in this particular possibility. As a result, what we can explore either with respect to time or with respect to position, the motion of object can be predicted. Anyways, let us try to consider the types of frame of references. The first type of frame of reference is called as a inertial frame, and second one is called as a non-inertial frame. This inertial frame of reference is also called as a non-accelerated frame of reference, and this is also called as a non-inertial frame, also called as a accelerated frame of reference. Now, in this particular case, all Newton's laws are valid, and in this case, Newton's laws are not valid. And in the inertial frame of reference, if the net force acting on system is zero, as a result, what happen? Acceleration A becomes zero. When acceleration is zero, either object will move uniformly or object is at rest. In such a case, we have that entire observation get together known as a inertial frame of observations. Now, let us see in the non-inertial frame. In the non-inertial frame, Newton's laws are not valid. Why? Because of pseudo forces is a new force. This will be present in the given system. As a result, the system cannot move with uniform velocity. Best example is nothing but a rotating frame is the best example. Example like Earth, where pseudo forces are present. Now, let us consider the inertia. Second concept in the Newton's first law, inertia. What do you mean by inertia? Inertia means a physical property which would like to always opposes the external acts or external agencies, or a physical property which would like to continue the same state. What is the state here? Either rest or motion. For example, object is at rest. You are applying a little amount of force, but system is not responding. Means it contains certain inertia. In another example, object is already moving. You applied a little amount of force, but object did not come to rest. In such a case, again inertia will arise. Anyways, this inertia can be divided into three types. The first one is called as inertia due to rest, inertia due to motion, and inertia due to direction. Inertia at rest. Best example. Suppose here is the beaker, and let us consider something like a cardboard over which a circular coin is exist. Now what we are doing is we would like to apply a little amount of external force on this particular card. Suddenly what happens, this coin simply fall down. So in such a case, inertia at rest, because the object would like to continue the same state of rest, external agencies are not impacting its state. So therefore coin would like to maintain the same state, but in air cannot possible to sustain, therefore it will simply fall down because of gravity. Anyways, situation, a bus is filled with of passengers, and if sudden brake is applied, what happens? Simply all the persons inside the bus simply fall in forward direction because of a sudden brake applied on the system. Why? Because our foot first will comes to the rest and remaining body in the same state of motion. So therefore, we'll try to feel in forward direction. As a result, this phenomenon can be understood. The second case is nothing but inertia due to direction. In the inertia due to direction, let us try to consider a simple case. Suppose if you try to move in the right side direction, you will try to feel in the left side motion. That is because of inertia due to direction. Anyways, this particular effect can be understood in the rotation process of a particular vehicle. Now, let us consider the next concept, that is called what do you mean by measurement of this inertia? Inertia can be measured with a physical quantity called as mass, and it can be measured with a physical unit called as kilograms. Anyways, this mass is of two types. First one is called inertial mass and another one is called as gravitational mass. The inertial mass of system is nothing but applied force by acceleration of the system. So this ratio applied net force to that of acceleration of this particular thing is called as mi, inertial mass. And what do you mean by gravitational mass? Gravitational mass means gravitational force called as weight, and you can write down as what? Acceleration due to gravity g. The ratio between the two parameters is called mg. On earth it is found that mi is always equal to mg. So therefore inertial mass contains the same to same value to that of the gravitational mass here. Anyways, let us explore the next point. Next, as we studied water, if we try to apply external force, then only the system may or may not changes the state. Two possibilities are there. So let us explore individually for a simple clarity. If the applied force changes the state, then what happens? And if the applied force should not change the state, what happens? Let us see one by one. Now, first one. If the applied net force not changes the state. That means whatever the force that you are applying does not produce any kind of modification. That means acceleration is equal to 0. When acceleration is 0 means two possibilities are there. Either delta V is equal to 0 or u is equal to v is equal to 0. Both are equal to 0. Two possibilities are there. First possibility is uniform motion. Uniform motion. Second possibility is object is at rest. There exists only two possibilities in the first case. Second case. Suppose you applied some force on the system. Then what happens? Now, first possibility. Object is at rest. Object is at rest. You apply force, then what happens? Starts motion. U is equal to 0, V is equal to something unknown velocity, and it is going on because of the external agency. Second case. Already object is moving with the uniform velocity U, and you added force along the same direction. Then direction cannot change, but initial velocity u transferred to v, final velocity v. Third case. Now, in this case, object is moving with the speed of u, but we are applying a transverse force of f on the moving object. Then, in this case, object would like to move in the rotational track with the uniform speed u is equal to fixed and experiences central acceleration AC. Next, fourth one. Suppose if we try to, this is the motion of object, and if we try to apply some tangential force F like this, then what happen? Object would like to move in the form of helix. Okay, we would like to learn about these three different case situations in the different cases in physics. Now, let us consider next case. How to identify the force in the universe? So the fundamental forces are divided into four types. First one is called as gravitational force, and the gravitational force is given by g m1 m2 by r square. And second force is called as electromagnetic force. That electromagnetic force given by q of you can take it as vector form e bar plus v bar cross b bar. You can write down. It's called electromagnetic force, also known as Lorentz force here. And we have a weak nuclear force followed by a strong nuclear force. So we have, these are the four type of forces in the universe, and how to identify them. And this particular thing can be identified at the charge part. Whenever there is a charge particle and experiencing electric field and as well as magnetic field or any one of the field only there, then that charged particle experiences electromagnetic. And according to the universal gravitational law, every massive substance, whenever there is a mass for the object, okay, there must be a gravitational force. That is a fundamental thing. That means take two pens or two objects separated by some distance apart. Definitely they have one attractive force called as gravitation force. Like this, you can identify. Example: there is a table over a book. Between table and book, there is a gravitation force. No problem. Let us take one more example. Two spheres are touching with each other. Center to center distance is nothing but 2r because they are identical and identical dimensions and identical masses. In such a case, distance between center of mass to center of mass is 2r, and they have again gravitation force and weak nuclear force and strong nuclear force. Weak nuclear forces are generally because of the formation of beta disintegration. We have weak nuclear force, and the strong nuclear forces are because of the interaction of the nucleons less than 1 fermi inside the nucleus. Anyways, the ratio of strong nuclear force to that of electromagnetic force to that of weak nuclear force to that of gravitation. This entire thing in the order of 1 is to 10 power minus 2 is to 10 power minus 7 is to 10 power minus 38. So this is the important ratio. In the examination, they can ask you between any two of the forces. For example, rate of change of momentum, linear momentum. To remove the proportionality symbol, I am using a proportionality constant k into dp by dt we can write down. Where k is called as proportionality constant already we know, and the k value is experimentally found to be 1. Now, upon substituting the value of a linear momentum p, then we have F is equal to d by dt of, we can write down mb. Here onwards we have three opportunities. Let us explore what are that. The first one is nothing but m fix, second one v fix, third one m comma v. Both are variables. Both are varying or both are variables. In such a case, when you try to fix the mass comes outside, then the net force acting on the system is equal to always, you can write down as m into dv by dt called as m into a. Next one, when you fix the velocity, you can bring outside the differential, you can write down as net force is equal to v into dm by dt, we can write down. And m and v both are variable. In such a case, we have to use UV method for the differentiation. Therefore, net force is equal to m dv by dt plus v dm by dt. Both things we have to write down. Anyways, now in mechanics, we have different type of systems, such that sometimes they given with a pulley and blocks followed by strings, inclined planes. Different type of things are given in the problem. In the combination only you have to find out the acceleration. Whenever you are determining net acceleration on the system, okay, that the entire net force will be equated to always effective mass into acceleration. So that using this one can find the acceleration of system. This will be happens by using some constraints we will see in the next coming slides. Next one is here, net force is equal to V dm by dt. In this particular case, mass of the system is varying with respect to time. In such a case, as mass changes means, you can take the best example as rocket propulsion, and you are filling a bucket by opening lid of a tap. In such a case, what happens? Simply mass increases with respect to time, but they have constant speed. Then you can count or you can measure the value of net force acting on system. If both are variable, means you have to use ultimately the final formula. Next, let us try to take care information of impulse. Impulse, the symbol for impulse is nothing but I or J, and it is defined as the product of large applied force into time of journey. Upon doing this particular one can count or one can measure the value of impulse on system. And the dimension and units are same to same that of linear momentum only. So the units are here, our dimension formula both are given by m L t power minus 1 dimension formula followed by units kg meter per second. Anyways, when you try to plot the graph force versus time, we have the graph. So the area served by this particular graph, okay, this entire area comes under impulse of the system. And the average impulse is given by integration of f dt, and the instantaneous impulse given by f into hyperfine time dt. Are the two impulses what we have to take. However, we can also use the value of I is equal to change in momentum, or this will be given by, so the change in momentum means what? Final momentum minus initial momentum given by mass common final velocity minus it. So you can write down the different type of forms for impulses. We will see in our elaborated way about impulse in the next coming slides. Next one is forces. So in physics we have different type of forces for mechanics. They are average force, instantaneous force, and a variable forces. What do you mean by average force? Average force means the F average is defined as mass times to that of average acceleration of the system. That will give you average force acting on system. And instantaneous force, the force at that momentary or instantaneous value known as instantaneous force you can take, and variable forces. Example, a force which is a function of time t, function of position, or function of velocity v. So these three kind of force functions are called as variable functions. However, these values are may fixed or they may be a variable. Two things are possible. If we have a fixed values means they have a constant values, and their variables means definitely they are depending on certain function, maybe a time, position, or velocity. Next one, we would like to deal about Newton's third law. In the Newton's third law, we need to explore about action and as well as reaction. Now, this is the wall and here is the block. You applied force F on the system. Then what happened? This wall will apply normal reaction in this direction. Okay, let us consider another example. Here is some table. We are imagining like this. This is a table. On the table, we have a block like this. Then this block will apply gravitational force of mg in this direction. As a reaction, we are getting normal reaction n. When you isolate the two quantities, so mg in this direction, and from the table we have normal reaction n in this direction. That means the first one is called as here, this is called as action, and this is called as reaction. So this concept of action and reaction is made defined for only whenever objects are in contact. But the concept of action and reaction also valid for the objects which are in non-contact, like gravitational force. How much amount of force Earth will exert on Sun, the same force Sun also exert on Earth, even though they are not in contact. That only the controversial here. Remaining all cases are there. Best example for another example for this is nothing but rocket propulsion. Whatever the thrust that is generated by the rocket that will act in downward direction, as a reaction, the Earth will flow apply some force called as reaction force, which will keep the rocket moving upward direction. Now, the second important concept here is nothing but law of conservation of linear momentum. Now, if the net external force acts on system is 0, in such a case, you can write down as F12 bar magnitudically equal to, you can write down as F21 bar. Now, let us try to multiply by time interval on both sides. That means we can write down as uh, force F12 here into delta T is equal to minus of F21 into delta T. I can write down. Here bar indicate vector form. Anyways, force acting on the first because of second. That means first object will try to change the momentum, linear momentum. Therefore, P1F minus P1I we can take, which is equal to minus of P2F minus, we can write down as P1F. We can write down like this in the form of vectors. Now upon exchanging this one, we have sigma P initial bar must be is equal to sigma P final bar. We can obtain this kind of formula. This is known as the law of conservation of linear momentum. Summation of linear momentums before interaction must be is equal to summation of linear momentums after completion of reaction. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.